Hello class, in this lesson we'll be learning about parallelograms. So think about what that word means to you, then I'll show you the math definition. So in a parallelogram we have a polygon with 4 sides, and both pairs of opposite sides are parallel. So you name it with its 4 vertices. You don't have to write the parallelogram symbol in front. So before I give you some properties, this is a common math abbreviation. You don't see this in other fields. If, spelled with 2 F's, is not a misspelling. That means if and only if. So we've seen it before. Basically means that the statement holds in both directions. So we use a little arrow here with arrows on both ends. And so for example, what have we learned about parallelograms so far? Well, we learned that we have a parallelogram if both opposite sides are congruent. Both pairs of opposite sides are congruent. And that also holds in the other direction. So if we have a quadrilateral and both pairs of opposite sides are congruent, then it's a parallelogram. That's what the if and only if means. Okay, we also learned if both pairs of opposite angles are congruent, it's a parallelogram. And we learned that if the diagonals bisect each other, it's a parallelogram. Now, one property we might not have talked about, but it's also true, is that if you have one pair of opposite sides that are both congruent and parallel, it's a parallelogram. So that comes in handy sometimes. So let's go about proving one of these. Let's talk about the diagonals of a parallelogram. So here's our picture. And how would we write, what would our last statement be here if we want to prove that diagonals bisect each other? What would have to be equal? Well, we'd want to say that AE equals CE, as well as DE equaling BE. So we should always end with what we want to prove. And how can we get there? Well, let's look at the picture. We want to show that AE is equal to CE. And we also want to show that DE is equal to BE. There's a lot of ways to go about this, but looking at the diagram and how I colored it, looks like we have 2 triangles that we should probably try to show are congruent. So we want to end this with some statement along the lines of corresponding parts of congruent figures are congruent. Lots of ways you can say that. You can say it with triangles. You can say they're equal in length because this technically isn't congruence. This is saying they're equal in length. So let's see. Well, they give us that we have a parallelogram, so that implies that the pairs of opposite sides are parallel. Well, how's that help us here? What type of proof should we go about doing? Well, since the opposite sides are parallel, we know that we have congruent alternate interior angles. So we definitely want an angle in there somewhere. And do we have another pair of angles congruent? Yeah, we have these vertical angles here. You could have also picked the other pair of alternate interior angles, but it would be a slightly different proof. And, well, if we do pick them, we would have angle, angle, angle. So we couldn't do it with just those 3 facts. But what else do we know is true in a parallelogram? We know that the opposite sides are congruent. So it looks like we'll have an angle, angle side proof. So what we want to get to is that those 2 triangles are congruent with angle, angle side. So let's see, we have those alternate interior angles that are congruent. So BAC and DCA. And we also have those vertical angles that are congruent. And we have our pair of opposite sides that are the same length. So we have angle, angle side. Therefore, our corresponding parts are congruent. And that shows that the diagonals bisect each other. We also have 3 different types of special parallelograms: the rhombus, the rectangle, and the square. And to help you visualize the relationship between these 3 figures, we have this Venn diagram here. So here we have the world of all the possible parallelograms. And over here in the blue oval, we have all of the rhombuses or rhombi. So all 4 of the sides are congruent. Over here in the red oval, we have all of the rectangles. And where they cross, their intersection, that's the squares. So a square is a rhombus and a rectangle. And we have some useful properties of these special parallelograms. We know we have a rhombus. if and only if the diagonals are perpendicular. Also, if the diagonals bisect the opposite angles, then you have a parallelogram that's a rhombus. And if the diagonals are congruent in a parallelogram, then you have a rectangle. So those all hold in both directions. So let's prove a couple of those. Let's start with the rectangle one. So we have this rectangle here, and we want to show that the diagonals are equal in length. So what are the diagonals? We have GI. We want to show that that's congruent to HJ. So how can we go about that? Well, let's go with the argument of corresponding parts again. So what two triangles should we look at? There's a lot of ways to do it. So here's one pair of triangles you look at. Look at this one in blue. And we want to see how that relates to this triangle in red. So we want to show they're congruent. It looks like we have right angles. But I don't think hypotenuse legs can be helpful here because we're trying to show the hypotenuses are congruent. So we got to think of a different way to show those two are congruent. So let's see. Well, we have a rectangle, so we have these right angles in the corners. And we know that all right angles are congruent, right? They're all 90 degrees. And what else do we have? We have this common side. And we also know that the opposite sides are congruent because it's a parallelogram. So that should give us side angle side. So let's go through that argument. So first we have our rectangle that's given to us. So we know we have a parallelogram with 4 right angles. And we know that GJ equals IH. I'm sorry, I changed the lettering around a little bit because I thought I fixed that. So looking at triangles JGH and IHG. So GJ equals HI. Now the corresponding pieces line up right. So what else can we say there? Let's do our hash marks first. And we have GH equals HG. What property is that? That is the reflexive property. Oops. Put that in the middle. Okay. And finally, we want to talk about our angles. So we know that those angles are right angles. And so we can say that they're congruent because all right angles are congruent. So now we have side angle side. And so those hypotenuses are also congruent. And finally, let's prove that those diagonals in a rhombus, they cross and make perpendicular, or make right angles, so they're perpendicular. So to say that they're perpendicular, that's stating that all of those angles around E all measure 90 degrees. So how can we get there? Well, we have 4 triangles here, and it looks like they're all congruent. So how can we prove that? Well, we have these angles here around a point, and what we know about those angle measures, they add up to 360. And if all 4 of these angles are congruent, then 360 divided by 4 is 90. So that's what we're going for. So before that, we have to say something else. Right? We have to say that the angles are congruent, or that their measures are equal. And we can get there if we can show that the triangles are congruent. All right, so now we have our goal. How can we go about proving that? Well, we have a rhombus. It's given to us. And what's a property that we know about a rhombus? Well, it's a parallelogram. So we know that the diagonals bisect each other. So we have AE congruent to CE and DE congruent to BE. All right, so a few different ways you can go about this proof. One way is to say that, hey, we have a rhombus, so all of those sides are equal to each other in measure. That's probably going to be the easiest way. So This is because we have a rhombus. Or you could call it an equilateral parallelogram, but I almost never hear that term said. So rhombus is a better term, but that's what they use in the problem. Okay, so how are all these triangles congruent to each other? They are all congruent by side, side, side. And there we go. So now the corresponding angles are congruent, and they all measure 90 degrees. In this lesson, we learned about different properties of parallelograms and how to prove them. Thanks for watching this video.